Hey everyone, hope you're doing well. So in this video, I'm going to show you how to do terminal settling velocity in Excel. So we've done this in class using iterative process for the general equation, right? We're not using the Stokes approximation here. So we're going to do this in Excel, and I'll show you two different ways, at least one, brute forcing it, and the other method is to use the if conditions, right? So let's put the given information, which is, particle density is given, which is row P, right? So which is insert symbol, row, insert, close, and then put P, and this has to be subscript, right? So make it, I don't know why that's so big. It has to be WP. So that's P. Let's fix the P to make it subscript. So we do that, and then it's done. Okay, and then we are also given the fluid density. So I'm gonna change that to fluid density and remove the P, right? And we're given the diameter of the particle, which is D, in mm, right? And then we can convert that to the meters. Okay, and we're also given the dynamic viscosity mu, right? So insert symbol mu. Okay, I'm gonna, because I want to keep the video short, I may move fast, but if you want, you can always pause and go back and look what I'm doing, right? So right now I'm just entering the information from the problem statement here. So particle density was given as 1077 kilograms per meter cube. Fluid density was 1000 kilograms per meter cube. And diameter is 6 millimeters. And then you can convert that to meters by dividing 1000, right? And dynamic viscosity is given as 0.001 PAS. Okay, so this is the given information, and I can make it yellow. Borders and make it yellow. So usually I put the given information in yellow, and then calculations in blue. So we can kind of distinguish what's known and what's unknown in a spreadsheet. All right, so we did this, and then the next step is for us to set up the iterations, right? So iterations, also just make a note, be careful that you're not putting the units in the same cell as your number, because we're going to use these numbers in the equations and formulas, right? So when we're doing that, you don't want to pull a number that has text in it. And if you write it as 1077 kilograms per meter cube in one cell, Excel thinks that it's text. So you want to be like putting that in a different cell. So when we use this in formula, it uses the number, right? So iteration. So I'm gonna set up my thing like this. So we need the velocity, we need the Reynolds number, we need the coefficient of discharge, we need the mu velocity, and we have to figure out the tolerance, and we'll check for the tolerance whether it's working or not. So which means I have to put the tolerance value here also, right? Tolerance is going to be 20 minus 4, right? So that's the tolerance I'm going to be working towards. So I want to get at least that much error to make sure it's a good estimate. So one is, first iteration, we said that we're going to use a Reynolds number of 0.5, right? And then for a Reynolds number of 0.5, we know that CD is 24 over RE, right? So which is this formula right here. I'm going to pull the Reynolds number. And then for me to calculate the VS mu, I need to use this formula. So which is 4 times 9.81 multiplied by rho P minus rho multiplied by D. 3 times CD multiplied by 0. Okay, so when we're doing this, it's important to like make sure you have the right number of parentheses, right? So the everything under in the denominator has to be in one parentheses, because so it does all this calculation first before dividing by the number at the top, right? If you don't put it in parentheses, it will do divide by 3 first and then multiply everything else. So, remember the order of operations. And, the other thing we need to do is make sure you have, because what Excel does is when you copy the formula down, it will kind of, keep changing the cells to the next reference cell, right? So B1 becomes B2, B2 becomes B3, B4 becomes B5, and so on. And we don't want that, right? Because my particle density is always going to be 1077. It's not going to change in the next iteration. So I want to make sure it always pulls that information from that cell. So what I can do is I can tell Excel to not change that cell when I copy it down. So you can do that by putting the dollar signs before and after. The quickest way to do this is, press F4. So particle density is going to be the same. So I have to change this to row S. I shouldn't be saying row P there. But B1 and B2. So if F4 doesn't work for you, just put dollar before B and dollar before 2. What that tells Excel is that when I copy the formula down, just because there's a dollar before B, it will keep the B constant. Okay, otherwise it'll change the B to C. Okay, and then same thing with 1. When you put a dollar before 1, it'll keep that one constant, and when you copy down, it won't change it. So, and then diameter, which is D, is also constant. So set that. But my CD value is going to keep changing, so I don't need to change that. And lastly, the row value is going to stay constant. So we're going to do that and then press enter. So, if you look at your notes, that was the first number we got, right? Let me change this to row S also, so I'm consistent with what I've done in class, right? So that P has to be S, right? Okay, so for the first iteration, we don't have to do tolerance because, I don't know my velocity for the first iteration. So I'm going to leave it like that. So for the next iteration too, I'm going to use this velocity that I just calculated as my new velocity for the next iteration, right? And then my Reynolds number is something I can calculate. I wish I put the Reynolds number equation here, but we know that Reynolds number is rho times V times D divided by mu, and this should be in your notes, or V times D over mu, right? So what we'll do is we'll look at that information here, go here and check. It is rho is again we're pulling the particle velocity and then multiply by V is going to keep changing, so you keep it, you don't fix it. And then D is this, fix it, divided by mu, viscosity is constant, so fix it. Okay, should be 64, right? So it has to be coming from the next cell. So it's 67 because we are calculating the fluid Reynolds number for that velocity, right? So you do that and then go to the next CD. At this point, the CD value, because the Reynolds number is 67, has to come from the second equation, which is 24 over RE, right? And you can see how this automation kind of fails, right? Because you're using different formula and you have to type it in each time, and which is not ideal, right? What you should be really doing is, if you drag it down, it should work. That's how it should be done. But for now we'll do this, but this is going to be the same. So we do that, and now I can calculate the tolerance. We said tolerance was calculated by taking an absolute value of old velocity minus the new velocity that we calculated divided by the old velocity, right? So now I can check whether my tolerance is actually less than that or not. So you can use an if condition. So you see, you can manually check and say, hey, actually, 5 is bigger than 1, 10 power minus 4. So I'd have to keep iterating, right? So instead of doing that, what you can do is you can use an if condition. So the way if condition works is you have to give it a logical test, which means you have to tell it what are we testing for, right? So we're checking whether my tolerance that I calculated is actually less than 10 power minus 4 or not, right? That's what I'm testing for. And what if it is true? So the tolerance, if it's less than that, we can say that pass, right? And you have to put the text in code, so remember. So tolerance check pass stop, right? So you can fail go, right? So what that really saying is like, tolerance check failed, keep going, right? So I should probably just say just fail or something like that. So when it fails, I know that I have to do more, right? So at this point, I can just copy the formula down, okay? So I can just, select all these cells and move it down. The only thing I need to make sure is check that my Reynolds number is still falling within these constraints. So if it doesn't, let's say if it's over 10 power 4, I have to change my formula, right? So let's keep going. Maybe I'll drag it down to like 10 iterations, and I can keep dragging this down to 10 iterations. Okay? I don't know what happened here. If this should also fail, right? Why did it? Okay, so you can see how this whole referencing works. So because I set my tolerance at B6, right? You can see because I did not fix that, it keeps changing each time I move it. So I guess this is a good way to show you how this dollar sign works. So my tolerance is always coming from B6, so I fix it. Now you will see that when I drag it down, it'll always stay B6. Okay. So actually my failure to do the right thing actually helped make a point here. So you can see that now, because it's always checking at 10 power minus 4, it fails until this point and then it passes, right? So, that's how we can kind of check. So the other thing that we need to do is just make sure whatever you're doing, this RE value is actually lining up with this correct number, right? So if it doesn't line up, then you have to change the formula. So let's say suddenly here it's like 10,000 something. Then you have to go back here and change the CD value, okay? For this one, this is fine. So the next problem, I think it is asking for like 8 millimeters. So all you have to do is change the 8 to 8 here, right? So again, this is still 1,000. So this is 10 cubes. So you don't have to change much. But yeah, and this also works, right? So 8 is fine. So let's say, you want to make this process also automated, right? Because right now what we're doing is like a really brute force method of doing it, and it's not really automated, right? So what I can do is I can have a nested if statement. So what nested if statements are, just like we added an if statement here. So if I'll change this to if condition or some kind of brute force method, or and this one will be nested if condition. So what I'm really trying to do here is, instead of me picking the right CD formula, I'm trying to make sure that Excel knows which CD formula to pick, right? So that is what I need to do. So, hopefully you understand how the if statement works when we did this here, right? So there is one logical test statement, and you can tell it what happens if it is true and what happens if it is false, right? So when you do nested if statements, right? So what we do is we have to do two if statements, right? Because in this case, there's only two conditions, right? So if it can either pass or fail. But in this case, if it's less than this one. If it's between those two numbers, you have to do this. If it's more than that, you have to do that. So there's three conditions. So we have to go here and tell Excel, okay, so check if okay, my logical test here is to check if my Reynolds number is less than or equal to 0.5, right? Which is my first step. So if that is true, what do? I do 24 divided by Reynolds number, right? That's my first thing I'm doing. So if that is not true, I have to check again whether it is more than 10 power 4 or in between 0.5 and 10 power 4. And it will only come to this statement when it's more than 0.5, right? So you can just say another if statement here. If it's less than 0.5, it will do the 24 divided by RE if that is true. If it's not true, it'll check again whether it's more than 10 power 4 or between those two numbers. Typing this whole thing is tough. So what I'm going to do is I'll just check whether it's more than 10 power 4, right? So if my RE value is more than 10,000, 1, 2, 3, 4, then that number is 0.4, right? And if it's false, then it has to use the whole formula, right? Which is 24 divided by RE plus 3 divided by square root of RE plus 0.34, okay? And that closes the inside if statement, and this closes the outside if statement. Okay, so right now it gave me 48 because it's 0.5, right? So I keep going down, and it shouldn't change because it should be the same numbers, right? So let's do it for 6. You can see that my CD value automatically fixes itself, right? So you can see which formula it's using and stuff. So hopefully it is using the same correct formula. I'm checking with my other numbers that I have here. So CD here, let's put 6 here. So for 48, it's 1.06, 0.5 and stuff. So, it's working, right? So other thing we can do is we can increase the particle size diameter so I get like really big numbers, right? Or let's say I put like 100. So you can see it's 53, right? So, here you can see this is failing because when it comes to 53, we really should be using like 0.4, right? So for example, if I come back here and I change the formula to 100 millimeters. So you can see this actually changes and automatically uses the right 0.4, right? That's because we have set the Excel in a way to make sure it picks the right formula based on the Reynolds number that is being calculated here. Okay. Hopefully this makes sense, right? And I hope that, you can go back and you can recreate all the stuff that we did. Okay. So you should be able to go back and say, um, do both this method and this method. Okay. And once you made this, you really don't have to like go back and do anything, right? So for the next problem, all you have to do is change the diameter and change the fluid density and the viscosity that is given, and this Excel file is going to do all that for you. So what will be due is that you make your Excel file for the brute force method and the nested if condition. Okay. And please don't cheat, or please don't send me Excel files from previous year. Um, you know, because that's not the point of this exercise, right? Because most of the times what I do is I go and look at the info, and my name is here, but if you submit somebody else's thing, then you will see that person's name. So just make sure you're not doing something nefarious and getting caught, right? Because that will affect your whole um, career and future. So don't cheat. This is pretty simple. If you want, just pause and look at the formulas. Okay. Uh, I think all the formulas are visible. I'm trying to see what's missing in my. Okay. So just pause. Wherever you need to pause, just pause. Maybe what I'll do is I will show all the formulas, and so if you want to like take a screenshot of this whole thing, you can do that. So let me do that. So you have this whole thing. So this is the final thing that we did. And then this is for the brute force method, which is like entering everything normally by hand. Okay. So just let me open it. So, this screen, just pause it here. And, if you need help, just copy this information and make sure you get everything in. Okay. Thank you. And please reach out to me if there's any questions. Bye.